Now here's a wild and woolly Bernoulli.
I'm so ready.
Great. See, y prime plus 2 over x times y equals negative x to the 9th, y to the 5th. Ooh, y to the 5th. Anything other than 0 and 1 there, and it is a Bernoulli. So we also have an initial condition. Y of 1 equals 1.
That stuff coming up.
Sure. So here in our Bernoulli, we have n equal to 5, right, from here. And therefore u is equal to 1, or y to the 1 minus 5, so y to the negative 4, which is 1 over y to the 4th. So u equals 1 over 4th root, or y equals 1 over the 4th root of u. That's complicated. If we solve this for y, see, we would have to multiply both sides by y to the 4th, divide both sides by u, then take the 4th root of both sides, and this is what we would get. That's why this is u. So we're going to need dy dx. So this is really u to the negative 1/4. So hopefully you can see that dy dx equals negative 1/4 u to the negative 5/4. Remember, we'd have to subtract 1 times du dx, the derivative of the inside function u, whatever it may be. So now we're going to substitute this back into the original equation for y prime. So here it goes in for this y prime, and then plus 2 over x, that was from the original, and then times y, well, y is u to the negative 1/4, see, that's from here, equals negative x to the 9th times u to the negative 5/4. Well, remember, we're substituting y to the 5th, and y equals u to the negative 1/4, so that would be u to the negative 5/4. Well, that sure is an ugly mess, but it sure is going to be nice when we multiply the whole thing by negative 4 times u to the 5/4. Notice u to the 5/4 times u to the negative 5/4 gives us 1. Negative 4 times 1/4 cancels. U to the 5/4 times u to the negative 1/4 is u to the 1. Negative 4 times 2 over x is negative 8 over x, so we got du dx minus 8 over x times u equals, and what happens here, we have a negative 4 times a negative x to the 9th, which gives us a positive, and u to the 5/4 times u to the negative 5/4 gives us u to the 0, which is 1. So now we have this nice linear first order equation. Integrating factor, not hard to find, e to the integral of negative 8 over x dx. Well, that's e to the negative 8 times ln of x, which is e to the ln of x, that to the negative 8, which is 1 over x to the 8th. And after multiplying by 1 over x to the 8th, actually you could call that x to the negative 8, we would have on the left side the derivative of x to the negative 8 times u, and on the right side, see, x to the negative 8 times x to the 9 is just x to the 1. So that's nice. And now we can integrate both sides. When you integrate this side, integral of derivative is just the thing. So x to the negative 8u. Integrating 4x, we get 2x squared plus some constant. That's the constant that's the combined constant from this side and this side. And we now have u equals 2x to the 10th plus c times x to the 8th. I hope you see where that came from, because we've got to multiply both sides by x to the positive 8 to clear that off. So we've got our u. Unfortunately, we don't have a y. But remember, u was equal to y to the negative 4, or 1 over y to the 4th. And so we now have this as our solution. Or maybe we could write it like this: y to the 4th over 1 divided by 2x to the 10th plus c x to the 8th. But we have an initial condition. If x equals 1 when y equals 1, then 1 to the 4th is still 1. This is 1, this is 1, so 1 equals 1 over 2 plus c. c, therefore, is negative 1. And the solution of the initial value problem is y to the 4th equals 1 over 2 times x to the 10th minus x to the 8th. Or y equals plus or minus the 4th root of 1 divided by 2x to the 10th minus x to the 8th. Solved. explicitly. And I guess I could probably simplify that further by factoring out x to the 8th from these two terms in the denominator. 4th root of x to the 8th would be x squared, so maybe plus or minus 1 over x squared times 1 divided by the square root of 2x squared minus 1. I'm not sure if it's worth it, but there we could say we have solved it explicitly, and I hope that's good enough.
I know.
Great.